So of course, after getting the bean, the next thing anyone would want to do is to design custom parts, right? The whole purpose of having a 3D printer is to be able to print out your own parts. And this, of course, is a bit of a challenge compared to the Rook, which, of course, has all preset settings and everything. And so what I happen to need is I take my footage now with Sony FDR X3000, and the X3000 has a lens cap, which they call the MCP1. It's not a lens cap. The MCP1 is really a neutral density filter. And they don't make a lens cap for the MCP1. So I want a lens cap for the MCP1. So I designed one to be a slip fit. Now a slip fit needs to be within, I think, a 1/10 of a millimeter or less to just get it right. It's got to be tight enough that it stays on, but loose enough that I don't scratch up the object that I am trying to wrap the lens cap around, right? Because this is going to be a slip fit lens cap. And resin printers are really good for this. With a good quality resin that doesn't have too much shrinkage, you can get very, very tight fits. And I've had good luck making GoPro lens caps this way before. So this is going to be an all new object. I don't have a lens cap currently. And it's a relatively simple part. This is going to slide itself over the lens. And then the lens is flush and there's a slight frame around the edge. And so I don't want this bottom surface here to come right up to the glass. I want to stand it off a little bit. So I've got these standoffs, the standoff in the back that will give me a that will hold pretty much an air gap between the lens and the front of this cap. From a printing perspective, then we have to think about, how am I going to print this, and what design features do I need to increase the chance of this being printable. In my case, I want to print this as a single part. I don't want to create any air holes or drain holes because it's a lens cap and I don't want dust getting in. So I either have to accommodate for this with my printing parameters, or I'm going to need to somehow prop this up or design a way to prop it up. Now, I'm pretty confident with a small part like this that I'll be able to print this flat against the build plate without any supports. Now, if I'm going to print this big surface area flat against the build plate, I just need to have a strategy on how I'm going to scrape it off. And for that, I've got a 1/2 millimeter fillet here, which will be just enough for me to get my my plastic scraper just started underneath here so that I can hopefully peel this off relatively easily. So simple part in Onshape. I'm going to export this now as an STL file. Put this here into my STL directory. And then I'm going to come over to my printer. If I were using supports, I'd need to go to a tool like Photocentric Studio, Formware, Mesh Mixer first to set up those supports. Since I don't have any supports, I can come directly here to and set this up. And what I'm going to use is the SLaser that's built into the Kudo3D user interface. Because of the way I'm recording this, I'm going to have to go there directly. And what that SLaser gives me is a place for me to quickly lay out and slice parts that already have the support set up. This won't create supports for you. You'll have to have created supports and exported the supported STL file, and then you can bring it in here. And so in my case, I'm going to grab that STL file, and I'm going to lay it down. And now, because I'm going to be printing it like this, I'm going to need to think about and imagine what's the best orientation for me to print this in that'll maximize my chance for success. And the way that I usually think about this is to think about, first, if this bottom surface, and the bottom surface is usually the most critical, or whichever surface is the biggest surface area, if this were a big sticky label, where would I start trying to peel off a sticky label with this shape? Would I start against one of these long flat edges? Probably not. I want to start in the corners. And so I want the peeling action to start in the corners. Then I have to think, well, where is the peeling action going to take effect on the surface of the printer? In the Titan 1, there was, of course, one fixed end and one floating end. And so peeling would always start on the fixed end. Here, I've got 4 fixed ends, right? I'm fixed around all the edges. And so what I really need to think about is, how do I orient this so I have the most favorable purchase, right? First peel oriented along these 4 hinges, right? Assuming that peeling is going to start in each of these directions. Now, since this object is rectangular and symmetric, it's pretty easy. What I want to rotate this z-axis 45 degrees so that the peeling action will begin in these small corners and hopefully then break any vacuum relatively quickly. So rather than having to peel up this whole edge here, one of the flat edges rather, when peeling, I can hopefully begin that peel right on a corner and reduce the amount of force. So I'm going to do this. I've got it oriented this way. I'm going to slice. Now, slicing will take a bit. I'm only able to slice at a couple of layers per second here. Partly it's because I don't have a super awesome video card. This does use your browser's video card for this. This is built in JavaScript using, in the backend is 3.js, and 3.js is WebGL enabled. And that means that it will use your hardware video acceleration through your browser in order to speed up its calculations. I don't have such a great video card here, and this is running on Linux, so it doesn't have the most awesome optimized video path, but it's fast enough, especially for small print sizes like this. Now, when this is done slicing, I can download the zip file, and I will save this off into my slices directory. Now, I'll go back to the Kudo3D user interface here, and I will upload those slices. So you can see here I'm uploading, and then this part appears here. I can open it, and it reads out 270 layers at a slice thickness of 0.05. This is fixed, so in order to use basic mode, you need to slice at 50 micron thickness, right, 0.05 millimeters. If I set SLaser to some other thickness, it would be a mismatch here. Then I have to get into the world of manual settings. I'm going to use green resin, and we can see that the basic settings are reasonably conservative. These are pretty good. For basic prints like this, you won't need to change this. These are quite conservative. I'm lifting pretty slow and lifting pretty high. Where if I had a more complicated mechanical part that maybe had big surface area and then small surface area and then big surface area, I might want to take a look at how I wanted to align these with my known surface areas in order to ensure that I had enough lift and was lifting slow enough for those areas. Similarly, if I knew that I had a part that had a lot of small surface area that didn't require super slow lift, 15 millimeters per minute is quite slow lift, then I could perhaps increase this. Similarly, if I knew that I was using some really thick resin that might need more settling time, I might mess with the delay time. Also, during the first layers, while the build plate submerged in the resin, there'll be more turbulence when the build plate lifts, say, 7 millimeters out of the resin and then pushes back into it. And so you might, with more viscous resins, need more delay at the bottom. But the Kudo3D default resin, the ones that ship, are pretty good. I don't really need to change any of these. And this is all set. So now I will head over the printer and begin the print. Okay, so I'm back at the printer now. I've got everything buttoned up from the last print. I've got this guy working now. So let's refresh the tablet here with the that I'm going to use to control. This tablet's a bit slow. And so we see that parts loaded, 270 layers down here. Let's make sure I've got, whoops, what's going on here? Make sure I've got this part loaded. White, black, green. Let's try switching. Go back to Rook. It's a little weird since I opened it on the other computer. Come back here, 270. You can see the settings here. Go to 270. Okay, so everything's set. Now I just want to zero and go. Before I zero and go, I'm going to do a quick check to make sure that nothing bad is going to happen. And what I'm going to do is I'm going to sweep the bottom here, make sure there's nothing stuck at the bottom of the vat. Because you definitely don't want, when this build plate goes down, for this build plate to hit anything down here and drive some remnant into or through the bottom, because the bottom is basically the LCD screen right up against the, or not necessarily right up, but with as little distance as possible between the LCD screen and the surface of the flex vat. That's just inherent to the design of all of these LCD monitors, because you don't want you don't want a bunch of optics down there. So that's good. I validated there's nothing down there, and so I'll put the lid back on, and then I will home the printer. Make sure there is no cured resin below the build platform. All right, proceed. So the stage is going down to the bottom right now. And I have a bit of a dance that I do from my experience with the Titan 1. So let's watch this come down. And right now, the build plate is in midair. And so when the build plate pushes down into the surface of the resin, it might carry air bubbles stuck to the bottom. And most of those air bubbles will push out when the build plate pushes down against the bottom surface, because the Z0 calibration, it should be real close. But there might still be minute amounts of small bubbles trapped at the bottom, and that can sometimes cause your first layers, right? You can see that some air got pushed out there. If there's any trapped air underneath there, you might see bubbles or other artifacts in those early layers. Now you can't see whether or not there's any bubbles, and so to kind of minimize the chance, what I do is I'll lift by small amounts. I'm switching here to 1 millimeters of lift, and I'll move up enough so that I can be confident that I'm above now, that I haven't sucked up the flex vat, the flexible film up with it, but I don't want to go above the surface of the resin because I don't want to incorporate any more air in. And then I'll go back down, so I'll home again. All right, and there's a little tiny bubble that came up, so that was good. And let me do that again. 1, 2, 3, 4, 5. 5 millimeters seems to be right for the amount of resin I have here. Let that settle, and then I'll go home again. All right, now I'm fairly confident that I've gotten rid of everything that I need to get rid of. Everything's set, my part. I'm reading 270, I know my settings, and let's print. Do you want to proceed? Yes. And we start. You can see with the preview here, estimated time about 2 hours because there's only 270 layers. And then I can see the layers going going along here. So let's let this run, and we'll come back, and hopefully there will be a part. Okay, done printing. Let's see what it looks like. So we got a part. That's good. So let's get rid of some of this excess resin on the top. It's good enough for now. Dripped a little. Let's get this guy off. Oh, it drips. All right, let's get rid of the excess resin here. Try to get as much resin off this part as possible. Okay, and then let's pop this guy off. There we go. Put this guy back. Let's double check to make sure there's no remnants down here so we don't get any surprises. If I zero it, it's always good to check obsessively. Don't want any crushing to happen. All right, so that's pretty clear. All right, so that's done. Let me put this back up. All right, so here's the part. Let me go finish this off. Normally I'd stick it into the ultrasonic cleaner as a first pass, but I'm in the process of settling and refreshing the soapy liquid here, so I'm just gonna skip straight to the alcohol rinse. So let me do a little bit of rinsing here, and then going. All right, that's pretty good now. And then I'll take a first pass into the UV curing chamber, which I do have the bean one, but I'm going to use this guy here, which I'd built previously, which is basically just ring of UV lights and a little rotating turntable. This turntable, you see a lot of people using a solar turntable, but I like curing certain types of flat parts when I print with the Titan 1, putting the whole build plate on top. And the build plate with the ball head and everything is a little on the heavy side, so I need a slightly more powerful DC powered one rather than just a solar powered one. So let me stick this up here. There's still alcohol in here, so I don't just want to close it completely because I don't want condensation to form in there. So I'll just do this like this, and then we'll come back and check to see what it looks like when it's done. Okay, so that's enough for a small part like this. Let's take a look at this, see what it looks like. All right. A little bit sticky on parts. Looks like I didn't... This protocol left a little bit of white residue at the bottom, where I guess the problem is that alcohol needs to evaporate off quickly, otherwise you get this. That's why we don't have it on the other side. That's an interesting finding. Alright, this was the part sticking down. This is the infamous white residue, which is on the unevaporated side. Alright, anyway, a little sticky, so I'm going to do a little underwater cure. This should be relatively fast. Let me put this on and come back in a little bit. Okay, let's get this out. Dry it off. There we go. Surface finish is now nice and not tacky. So while, who was it that first blogged about the underwater technique? I remember a resin company in Oakland that went out of business. The company's long gone, but technique still remains. This was an accidental discovery. It seems like you should not begin post-curing unless you are sure that your alcohol is absolutely dry everywhere. That may be the source of the mysterious whiteness. So let's check the dimensions of this. This is supposed to be 48.1 millimeters. We've got here 48.12. So this is like, this is spot on. Yeah, that's pretty spot on. And then this side is supposed to be 35.85, 35.9. So really to within 50 microns. So to the resolution. Final thing is, did I design it properly? These are the correct dimensions. Did I design it properly to fit? So let's try it on the camera. Alright, I made it too loose. Okay, not a fault of the printer, but it's a little loose. In order for it to be a firm, it does hold on itself kind of. Like, hey, no hands. But it's still a little too loose. So I need to go back and probably take this down by another 0.1, 0.2 millimeters. It's very close now. But I'm quite pleased with the dimensionality. Dimensionality in XY seems to be within 50 microns, 0.05 millimeters, which is the theoretical amount. The material is good. The Kudo3D resin, this is not a huge print, doesn't seem to have a significant amount of shrinkage that throws that off. So it does seem like you can reach the theoretical amount of dimensionality with the bean. Yeah, 0.15. .9, yeah, good. And that's it. Nothing wrong with the printer, although I do need to make a design change. Thanks for watching.